Hi everyone, welcome to Shrek Studies. In this session, we are going to discuss the important concept on Power System Analysis 1 on the third module, a derivation called a expression for symmetrical components to phase voltages. Here we are having the phase voltages as a VA, VB and VC. We are converting in the terms of VA0, VA1, VA2, that is symmetrical components. VA0 is nothing but 0 sequence, VA1 is a positive sequence and VA2 is a negative sequence. We are taking the transformation matrix as a, let us take the transformation matrix, that is T is equals to 1 1 1 1 1 A square A square. Okay. We already know that the expression for the phase voltages to symmetrical components, the equation is given by, it is given by VA, VB, VC is equals to transformation matrix of VA0, VA1 and VA2. Okay. We want now symmetrical components, right? So, VA0, VA1, VA2 is given by T. If I transpose this side, it will become T inverse of VA, VB, VC. Okay. And we know that the inverse of T is given by adjoint T divided by determinant of T. Okay. So, for this we need to calculate the determinant of T and adjoint T, right? First we will calculate determinant of T. Okay. This is a given matrix. For calculating the determinant matrix, we know that plus minus plus will be there. Okay. See now, for first we are taking the 1. So, eliminate the first column and the first row. Then what will be left here? 1 into a power 4 minus a square. Okay. Again we are taking the minus 1 now. That is, this is C11, this is C12 and this is C13. If you are taking the minus 1, eliminate the second column and the first row. If you eliminate the second column and the first row, the what is left here? A square into a minus 1 into a square minus a. Okay. Again likewise third term. If you terminate the first row and the third column, we will get 1 into a minus a square. Okay. Now a power 4 can be written as a and a square will keep as it is. Why? Because see here, as we know that a is equal to 1 with angle 120. Then a square can be written as angle 1 with 240. Then I can write a cube as a into a square. So 1 into 120 into 1 into 240. It becomes 1 into 360. So I can write a cube as a 1, right? Okay. Then if a cube is 1, I can write a power 4 is equal to a cube into a, right? A cube is nothing but 1. So I can say it as a power 4 is nothing but a, right? Okay, that's why I written a power 4. In the place of a power 4, I have written a. And I am keeping a square as it is. Okay, here take minus as a common and keep it as a minus a square. And here also a minus a square. Plus, here I am taking minus as a common, right? So, all are like terms. These can be added 3 times of a minus a square. So, the determinant of T we got here has 3 times of a minus a square. Okay. Now, we have calculated the determinant for this matrix. Now, we need to calculate the adjoint, right? So, let us calculate the adjoint T. See, remember one thing. For calculating the adjoint T for 3 into 3 row matrix and column matrix, we are having the signs as plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay. Respect with this. See here. See, we are calculating for the first, right here. That will be getting, we will get same this one only. If you eliminate the first column and the first row, will get as a power 4 minus a square, plus should be there here, and again here minus. If we calculating for 1, we will get a square minus a. If we calculate for 1, it will get as plus 1 into a minus a square. Okay. Now we calculate for C21, column 1 second row, column 1 second row. If we calculate for C21, Here we will eliminate the first column and the second row, and we will get, if we eliminate the first column and the second row, we will get a square minus a. Okay, we will keep here minus sign because see here sign is minus, that is a square minus a. Here we need to keep plus. For this, if we eliminate the second column and the second row, you will get a square minus 1. Okay, likewise for all the terms. Here we have plus minus sign and a minus 1. Calculate for all the terms. A minus a square minus a minus 1 plus a square minus 1. We got adjoint t equation as like this. Okay, we are minimizing, that is we are taking a minus a square as a common for the further simplification. See, in place of a power 4 I am writing as a. Why? Because we already say that a power 4 is nothing but a. Okay, a square I am keeping as it is. Okay, again here a square is there, I am taking minus as a common and a minus a square. Here a minus a square already is there, keep like that only. Again here take minus as a common and make it as a minus a square. This is a square minus 1 is there. I am multiplying a to it. See, if I multiply a to it, a into a square we will get again. Okay, same term. A into a square is nothing but a cube. A cube is nothing but again 1. We are getting the same term, but we are making it in the form of a minus a square. Okay, to take common. And again here see a minus 1 is there, we are multiplying a square to it. A square into a is nothing but a cube, that is 1 we will get, and a square into a square is nothing but a power 4. A power 4 is nothing but a. I have written this is as a in terms of minus only. Why? Because to take a minus a square as a common. Again this is in the form of a minus a square, keep it as it is. This is a minus 1 is there, multiply a square to it. Again if you multiply a square into a cube we will get. So a cube is nothing but 1 and a power 4 is nothing but a. We will get as 1 minus a. We took minus as a common and we have written in the terms of a minus a square. Okay, same wise here also multiply a to it. If you don't understand this logic, let us write a minus a square for all these terms, 1 1 1 and 1 1 1. Okay, and whatever the term is there in the previous, no, write that only here. Okay, you should write a minus a square, a minus a square, a minus a square, and see here. For these two terms, you multiply a to it, and for these two terms, multiply a square. That's it. If you don't understand the logic, just remember in the simple terms, write all the terms as a minus a square. All the terms. Then for these only 4 terms, crosswise. If you take here a and for this a square and a square. This is a simple thing to remember. Okay. Now what we are observing here, a minus a square is there in all the terms. So take a minus a square as a common. Okay, then what is left? Here 1 1 1, write it is. Here also 1 1. Okay, here a square a. Okay, this is the we got as a adjoint a, and we have in the equation that t inverse is given by adjoint t by determinant of t. So write in this equation, that is t inverse. What is adjoint? This is a minus a square 1 1 1 1 1 a square then a. Okay, and divided by determinant of t is there. What is the determinant of 3? We have got 3 times of a minus a square. Write that down. 3 times of a minus a square. Okay, we can cancel these 2 terms. So t inverse will be 1 by 3 times of 1 1 1 1 1 a square a square. Okay, so therefore I can write it as VA0 VA1 and VA2 is given by 1 by 3 times of 1 1 1 a square a. So if I write in the equation form, VA into, we are taking the phase voltages, that is VA VB VC. Okay, and if you write in this equation in the form of equation of phase symmetrical components, VA0 will be given by 1 by 3 multiplying the row with this column. Okay, we will get as VA into 1, VB into 1, VC into 1, VA plus VB plus VC. For VA1 we will get as 1 by 3 times of VA, A into VB A square into VC, that is A square VC. Okay, for VA2 again 1 by 3 times of VA into 1 VA square into VB, that is A square VB, then A into VC. Okay, this is the expression for the symmetrical components to phase voltages. If you like this video, please like, share and subscribe to my channel. Thank you.